All right, we're at section 15.6, the Millikan oil drop experiment. And Millikan, from 1909 to 1913, Millikan performed a set of experiments that he measured the elementary charge of the electron and demonstrated the quantized nature of the charge. The figure shows his experiment. You could view the oil drops dropping through this pinhole, and if there were no if the electric field was off, then the droplet would just fall at the terminal velocity v, because the gravity and drag forces would sum to zero, and it would just fall at some terminal velocity. Now, if he turned the electric field on, the droplet would move upward, and a new terminal velocity would he'd see a new terminal velocity. The gravity, the drag, and the electric forces summing to zero. And he noticed that there were differences in the rate, and he was able to come up with the idea that the electrons were quantized, that there was a certain value, and he developed it within a certain percentage. I lost that part of it. With about 1% precision. And in 1923, he was awarded the Nobel Prize for this. Now let's do a new share, and let's look. I'm going to look for my mathematical. There it is, my mathematical. We have an oil drop experiment, and let's play this. And there's going to be, you're going to see these drops falling with the electric field off. You'll see some that are black; those are neutral. There's no charge on them. Some will have a single negative bar. Those are negatively charged. Some will have a plus green bar. Those are positively charged, and we'll turn the electric field off and on as we go through this. So let's turn this on. Oh, let's show the particles. You can see that it's positive, so the positive is repelled. The negatives are attracted to the positive, and you can see that you can control the falling drops. Let's do some more, and if we go back and forth, there's no change. Why? Because there's no plus and there's no negative. These are neutral. So let's do it again with a new set, and let's change the. You see the neutral, these two neutrals, they go, it doesn't matter what the field is, but the positive and the negatives, they go, notice this double negative is going much faster than the single negatives. And of course, it just stopped on me. Well, that's good enough. I think that demonstrates the Millikan oil drop experiment. So let's do a new share, go back to the PowerPoint, and then we're going to do here he discovered that their charges was quantized. That means it's going to be plus or minus. It's going to be NE, where N could be 0 if it's neutral, plus minus 1, plus or minus 2, plus or minus 3 times E, and where E is 1.6 times 10 to the minus 19 coulombs. Okay, let's go to the Van de Graaff generator. The Van de Graaff generator is this belt, and you've got these little fingers that place positive charge on the belt, and the belt, as it passes this metal dome, will gain the charge, and as the belt comes down, it's neutral. The charge is deposited on the belt at point A and transferred to the hollow conductor at point B, right here, and it can build up enough charge that once it builds up enough charge, it breaks down and you get this lightning bolt. This fellow is protected because he's in this Faraday cage. Let's see, is there any more to say about the because the electric field inside the metal dome is negligible, the positive charge in it can easily be increased regardless of how much charge is present. The accumulation of charge on the dome can't continue indefinitely. As more and more charge appears on the surface of the dome, the magnitude of the electric field at the surface also increases. Finally, the strength of the field becomes great enough to partially ionize the air near the surface, increasing the conductivity of the air. Charges on the dome now have a pathway to leak off into the air, producing some spectacular lightning bolts as the discharge occurs, as you can see in this photo here. And with that, we're going to stop. We're going to go on to electric flux and Gauss's law in the next section, which I think is the last section of the chapter.